Everybody. Our next session is entitled The Future of Robotics, and it's a chat between Professors Pieter Abbeel and Joey Gonzalez. And I'd just like to start by giving a kind of short introduction to both Joey and Pieter. So Joey is a professor in the EECS department and is co-director and founding member of the UC Berkeley RISE Lab and a member of the Berkeley AI Research Group, the BEAR Group. His research interests span machine learning and data systems, and he has a wide range of projects. In 2020, Joey launched a new stealth company based on his research to radically simplify the process of deploying advanced analytics and machine learning in modern data-driven enterprises. Prior to joining Berkeley, Joey co-founded Turi Inc., formerly Graph Lab, which was based on his thesis work on the Graph Lab and Power Graph systems. Turi was eventually acquired by Abbeel. Now let me introduce Pieter. Pieter is director of the Berkeley Robot Learning Lab and co-director of the Berkeley Artificial Intelligence, or BEAR Lab. Pieter has founded two companies, Gradescope, which is a company which uses AI to help instructors with grading homework and exams, and Covariant, which is a company about AI for robotic automation of warehouses and factories. Pieter is a founding partner at AIX Ventures, a venture capital firm focused on AI startups. He is the host of the Robot Brains podcast, which explores what AI and robotics can do today and where they are headed, through conversations with the world's leading AI and robotics pioneers. Pieter has received many awards and honors, including the PCASE NSF Career, ONR Young Investigator Award, the DARPA YFA, the TR35 IEEE Fellow, and the ACM Prize in Computing. His work is frequently featured in the press, including the New York Times, Wall Street Journal, BBC, Rolling Stone, Wired, and Tech Review. So please welcome Joey and Pieter.
All right, so I'm going to be asking Pieter questions, and I'm going to start with a funny question that's sort of a little bit of my backstory, and Pieter I don't think he knows this. When I started my PhD, it was 2006 in Pittsburgh, and the very first conference I attended was ICML in Pittsburgh, and the very first talk I ever saw was Pieter as a graduate student. At that point in time, he was flipping helicopters using graphical models, inverse reinforcement learning. It was very cool stuff. I went to my advisor basically after that talk and said, I want to flip helicopters with neural networks. He's like, well, two things. First, flipping helicopters is not that useful. And second, neural networks are not the future. He was half right. Neural networks turned out to be pretty useful. 4 years later, or 3 years later, I think you went on the job market. I was one of the grad students in charge of trying to recruit you to come to CMU, because I thought Pieter would be awesome at CMU. He made, I think, the right decision and went to Berkeley. Maybe you could talk a little about that decision process. Why Berkeley?
Yeah, and thanks, Joey, for hosting. So I remember visiting CMU, actually, meeting the students and having a really, really good time. Ultimately, I think these decisions are pretty hard when you have to choose between different top schools. But to me, at the end, it felt like a pretty natural decision in that if you want to be both at the frontier academically and in the entrepreneurship world, while not being constantly distracted by people trying to pull you every day into the next startup left and right, and allow yourself a little bit of focus, you only have one choice. You pretty much have to be at Berkeley. You can do your work, and you're close enough to go do the other things whenever you want to.
Yeah, I had a similar decision process myself, and definitely kind of same conclusion. So I'm going to talk a bit about, and we'll go into entrepreneurship, but I want to start maybe on the AI front, because that's where it's pretty exciting these days. Pieter is one of the thought leaders in AI and robotics today. And maybe we'll start with the kind of high-level question. Where do you think the field is headed? And what are the next big problems that we need to solve?
Yeah, I think different people will give different answers on this, so just one opinion. But to me, what's been most interesting in the last, let's say, 5 to 10 years, obviously 10 years ago, big transition from, including your advisor, essentially nobody except for Jeff Hinton, Jan LeCun, and Yosha Benjo, only those three believed in neural nets, to everybody realizing neural nets is the way to go. and seeing neural nets take off in a way that I think surprised pretty much everybody, including the three of them, how well, and after trying for 30, 40 years, all of a sudden things actually work and work in amazing ways. But I think the big recent transition that's exciting to a lot of us here is the first takeoff of neural nets, 2012 till about 2020, was you find your application, you find a lot of data for your application, you pile it into your neural net, train it, and your neural net will be good at that application. But it would be very specific. It would be a neural net for character recognition or a neural net for sentiment analysis of a document and so forth. And I think the big change recently is that it's possible to essentially pile all your data into a single neural network and end up with a neural network that is better at any one of the niche applications that before we would train niche neural nets for. And it's very, I would say, counterintuitive. Like most of the time when somebody tells you I'm better at everything, you're like, you must be worse at everything, just kind of decent at everything, but worse at every single thing. But with neural nets, the exact opposite is happening, is a single neural net that's asked to do everything ends up being better even at the specialized things. And so these large pre-trained models, foundation models, and so forth, I think it's a bit of a surprise and really exciting.
Yeah, I've noticed that myself. Again, as a PhD or as an early grad student, I came from Caltech where neural networks were still a little bit in vogue. But at basically CMU and basically the entire machine learning world was very excited about probabilistic methods. We went through fads, basically. There's excitement around probabilistic methods and these non-parametric techniques, these very large models. We got really principled with regularization. And then deep learning took off. And you were one of the early pioneers in using deep learning. We'll come back to some of your early work there. So you've already pointed to, we're seeing this trend now where people are converging on these large foundation, just large models that embody knowledge that can be used for all sorts of applications. And that's changing kind of the interaction between training, inference. What does that mean for companies trying to build in this space?
Yeah, I mean, let me actually sidetrack for a moment here and highlight just one specific company to how I think probably most people have seen the kind of most famous large model is the ChatGPT model, right, out of OpenAI. And you can talk with the chatbot about anything, and it's just a good example of kind of the non-specialization of these models being so strong. And even when you talk about something specific, it's going to be better than any other chatbot anybody build trying to address that specific topic. Of course, it still has many limitations, but it shows a very clear trend. And part of why I also want to highlight it, of course, is being at a Berkeley event here, ChatGPT was actually the lead at OpenAI is John Schulman, who graduated from my lab here at Berkeley. And his work was on reinforcement learning, some of the first real breakthroughs in deep reinforcement learning. And the reason I'm bringing it up is it's really bringing a new type of training forward in that the previous generation of training of the large models was next word prediction. What's the statistically most plausible next word to fill in? But that doesn't give the bot any purpose. And it's just doing whatever the statistics on the internet tell you. It's just based on those statistics. But so John brought in reinforcement learning. And by bringing in reinforcement learning, you can give it a purpose because you give it an objective. And so specifically what he did, he said, have people have conversations with the bot, have the bot generate multiple responses, have people rate the responses, and from that, the bot learns the pattern of what people like more and like less and starts tuning in on that and generating much more meaningful responses. It's not all the way there. Obviously, I'm not saying the problem is solved. There's a lot of research to be done. But it's a very interesting trend from just next word prediction to trying to give the AIs a purpose in what they're predicting. Obviously, if you follow the news, these bots are not very truthful at times. And there's new trends where it's combined, and I think you're doing some work on that also here, where it's combined with retrieval. You don't just reply, but you also show the documents that back up evidence for your reply, and you're forced to use that backup evidence. And in fact, there's a new startup out of Berkeley called Perplexity that commercializes exactly that. It's a ChatGPT, but with evidence backing the responses. And so I think these things are, I mean, these are some of the hottest companies in the space, but I think there's a lot more going on, obviously, than just that. And going back to your question, I think one of the big things is, a big question becomes, will everybody still train their own models? I think that's the big change, is until a year ago, you start an AI company, you're going to train your own model that's specialized for your application, serve it up, and have the best model for your application. But now you start an AI company, maybe you actually use an OpenAI or a Perplexity or a Cohere or yet another model from somewhere and layer something on top of it rather than building the core model yourself. Because some of these core models take millions of dollars in compute power to train just once for one generation. So it's different.
Yeah, it's changing the dynamic. One of my colleagues, actually one of Claire's former students at Kleiner Perkins, has been kind of exploring this hypothesis that these large models are sort of maybe analogous to the chips of the 1980s, 1990s, where there's one corporation that's capable of really building these really big models, and the technology world starts to build on top of it. And I think we're seeing that in the startup space, where a lot of companies are basically building technologies that sit on top of these very large models that cost millions of dollars to train. Now, it's sort of a problem for some of us. So in my lab, we study how to train large models, but we can't afford to actually train the models at the scale that these hyperscalers are training. And you hit on something that's kind of more fundamental, which is they're building these feedback loops of data. When you work with ChatGPT, that interaction is actually helping them build a better model. And again, in academia, this is a challenge for us because we don't have these feedback loops. And maybe kind of another question, and I don't have good answers for this, is how do we interact? What's the role of academia and industry when there's these high-cost models, these need for data feedback loops, but we have a lot of smart grad students that could be really making progress in these problems?
Yeah, I think, I mean, yesterday, two of my grad students asked the question. They just submitted their papers, and they're like, okay, just wondering, what are we going to do next? Because it seems like if people just keep scaling up their models, they're just going to have better results than whatever we try to do, and it's very hard to compete with that. But I think it's a big space, and I think there are areas where it's very hard to compete. If you want to build the world's best large language model, well, maybe you can do it in academia if you have a $100 million grant at your disposal for your single project with your single grad student running that $100 million project. But usually if you get a large grant in academia, it's actually split over so many faculty that ultimately no single faculty or student has a whole lot of budget to work with. But the way I like to think of it is to think of essentially where are things going to asymptote to? So the current generation of language models is in some sense asymptoting to statistically plausible generations, but it's not incentivized in the right ways yet to be truthful. So what are the missing pieces to make them truthful? Other things that are missing is they're not grounded in the real world. They don't know physics, and that limits their generalization. And when you see these fundamental limitations, you don't always need to be at the largest scale to investigate them. And so there is a lot of opportunity at smaller scale to hit up on these things that are going to have to be resolved. And so usually the question I like to ask is, what is guaranteed to be part of the AI of the future? Let's say, think 20 years ahead. What is guaranteed to be there, but is not part of, let's say, these large language models today? And pick one of these pieces that you just know is going to be there. It has to be, maybe some that will not be truthful, but the ability to be truthful has to exist. Right. The ability to reliably retrieve and provide evidence has to exist. The ability to have a purpose, for example, to convince somebody of something, has to exist. Or if you start looking at the robotics space, the counterpart would be video prediction. Can you imagine all possible visual futures of the environment around you? These things have to exist 20 years from now, probably sooner, and they don't exist yet. And so then find a smaller part of that puzzle to already make progress on now. The other thing, by the way, I want to highlight, Joe, I think Kurt sitting right in the front row here, Kurt Koitzer, is I think there is a whole big research space that Kurt has kind of pioneered here at Berkeley, which is focused on how to make these models more efficient. So right now, everybody knows OpenAI has trained GPT-4, which is supposed to be this mind-blowingly, even way more capable model than what's powering ChatGPT. But it's nowhere used. Why is it nowhere used? It's too expensive. Even though it's been trained, the tens of millions have already been paid for the training, just running an inference through it to make a query to it is too expensive. And I mean, the cheaper inference was something people were not paying attention to. But in academia, people have the time to think what's going to be next. And Kurt, 5, 6, 7 years ago, already started working on that. So I think there's a lot of opportunities when you think just a little further in the future compared to what the hottest thing is right now.
Yeah, I like that way of thinking. I tell my students there's a bandwagon right now. We're not getting on that. We're going to figure out where it's going. And so when we think of, in fact, Kurt and others were looking at this 6, 7 years ago, the inference problem. Like, we're going to solve AI, well, eventually, hopefully. And then once we do that, what are the next big problems? So we've talked to our colleagues even today at companies like Google, where it would be great if these large language models were in every single query. But they're so expensive to run every single prediction. We actually, in my group, stood up OPT, which is an open source version of GPT-3. So it's a 175 billion parameter model. And we had to get a certain amount of machines. A university in the Middle East actually donated to just run at 20-second response time. So it takes 20, 30 seconds for us to give you your answer. ChatGPT is instantaneous. It takes an enormous amount of compute to support it. And yeah, definitely a big area of future research. Maybe on the data front, any thoughts on what's the role of data moving forward for AI?
Yeah, I mean, a lot of complicated questions. There's questions who owns the data. There's lawsuits happening right now against kind of art that's generated. The companies generating art through AI as the mechanism to generate the art. Companies being sued, making money off of effectively the beautiful art that was generated by humans before that, some of it copyrighted and so forth. So I think there's a lot of, I guess, kind of ethical, societal questions, privacy questions. From a research point of view, one of the questions I'm most excited about, and actually tomorrow we're kicking off a new project at Berkeley sponsored by Office of Naval Research with about 10 faculty and many, many students on the role of active data collection, which is something that hasn't happened much. So right now, everything that's done is let's grab as much data from the internet as possible and train on it and see what happens. But the way humans grow up, they actively explore their environment. And there might or there might not be, I mean, it's an open question, but there might be something where if your AI, your robot possibly, because it might help to be physical, and to go around in the world for at least visual exploration, it might help to be able to actively select things, interact with them, and learn somehow a deeper understanding of how the world works, or much faster, get a same kind of understanding, needing maybe less compute, because the data is of higher quality. And that thing has already been proven out. If you look at the part of high quality data being important, if you listen to the chatter of why the OpenAI model might be so good and why maybe the Google bots maybe aren't as good just yet. The rumors are more along the lines of they've done an enormous amount of effort in curating the data that's being fed to train the OpenAI bots.
Yeah, it makes sense. With my startup, we've been working with a lot of companies using machine learning today, and they're not using ChatGPT. In fact, in many cases, they're not using deep learning. They're really focused on getting the right data, and often the data is the biggest problem that people have when using machine learning in the real world. I have some students who've been doing some of this generative work, and I've actually seen the model generate copyrights on the front of the images, which is funny because clearly it stole some copyrighted images to learn to write copyright in front of the images that it's generating. So yeah, it's an interesting world we live in when these models are, in a sense, creating data that has its own ethical challenges, and yet also the application of machine learning itself is so tied to data. And for academics, this has become both maybe a challenge and an opportunity. We're building our own data. We're also having the trouble of getting good data sets that the OpenAI has curated. So it's so critical. Maybe one more thought on ChatGPT, and then I want to switch to robotics. So we're all using ChatGPT, and in fact, there's a letter going around campus about what to do with ChatGPT in exams. And so should students be allowed to use ChatGPT? Should we be detecting if they're using ChatGPT on their exams? Copilot, another great tool. It can answer your coding questions for your exam as well. How do we approach that? Is that something we should be teaching you how to use ChatGPT, Copilot, to be more effective as a human, or should we be detecting it and preventing it?
I think it's a hard question. I mean, you can even trace it back all the way to things like, should you learn that 2 + 2 is 4, or should you just learn to punch it on a calculator? And now maybe just ask ChatGPT, what is 2 + 2? And hopefully it says 4. It's not that good at those things. Yeah, I think there's a distinction between, developing your brain and learning to do things yourself and being maximally productive by maximizing the tools you use. And I think in an ideal world, they tend to largely go together. And so ideal world, I think you somehow leverage ChatGPT and Copilot to be more productive and learn with it. But I think sometimes you gotta go through a phase of doing some things yourself to kind of get the foundations. Like, I don't know if I had never learned to count, let's say, or never learned to do 2 + 2 is 4 kind of things. I don't know if that would, how I'd have learned calculus next, and then the next thing, and the next thing. So it seems like maybe this is just off the cuff, and this is not a final opinion, and definitely not a Berkeley opinion, but it seems like maybe in some intro class, the very first intro class, maybe it's ideal to still write your code yourself. But then at some level, when the classes, you get further along in higher level classes, it seems more ideal to use all the tools.
Yeah. I don't know the answer to this either, but I've been asking my grad students to run their papers through ChatGPT because it improves the writing quality pretty substantially. Yeah, so I do see there are certainly opportunities to make people more effective using these tools, but finding the right balance of how to learn and how to use these tools is something that we'll have to figure out.
Yeah.
So I want to transition to robotics a little bit, since it's an area that you've been working on. And getting back to, you were once flipping helicopters, and then I think a little bit later you were folding laundry, some of the first neural nets to fold laundry. It's very cool. I'm still folding my laundry a decade later. Why is that? And when will these advances in AI and robotics start to become really consumer?
Yeah, I think well, first of all, I'm sorry you're still folding your laundry.
You would agree with me too, yeah.
But I think you're not alone, luckily. Okay. I think that's pretty much everyone, unless they have somebody do it for them. So there's been a lot of attempts, including we had a pretty successful run here at Berkeley, having robots organize laundry, at least towels and some T-shirts and so forth. In the end, I think that the challenge with bringing robots into the home is kind of the bigger picture challenge is robotics becomes harder the more open-ended the environment is. And so the more variation, the more variability, the harder it becomes. And of course, self-driving cars is the kind of most prominent, visible example of this. Driving is always different in unexpected ways, and that's why it's so hard to build a reliable self-driving car, because you can't literally prepare for everything. You have to somehow internalize something more general that we haven't, I think, figured out in the AI world, is how to get that very general pattern internalized. Yeah, so I can't give you a timeline. It's just like trying to make as much progress as possible. What I am seeing, though, is the same trend in robotics as we're seeing in language, which is a single model to rule them all kind of trend. So if we look at Covariant, my company that I started with a few Berkeley grads, we build the artificial intelligence for warehouse pick-and-place automation. And again, if you go a few years back, you'd probably think, I need to build a specialized AI for picking groceries, and then build a separate specialized AI for picking clothing items, and a separate one for picking electrical supplies and so forth. But what we found is that training a single neural net on all the types of SKUs you see everywhere is more capable than a specialized model. And I think that's really interesting because, of course, the reason that's happening is even in a specialized space like, let's say, groceries, there's so much variation that there's always things you haven't covered. And because there are things that you haven't covered, by also seeing electrical supplies, also seeing clothing, you actually have a higher chance of having seen something still that's somewhat related, and it somehow infers the right thing to do. And so I think the big trend is also these very large models that somehow become more robust, not by trying to make them more robust directly by saying, let's robustify in some robust control way by having somehow larger margins or something of error, but by having seen more. And by having seen more, being able to generalize better onto the next thing you see.
Cool. You touched on autonomous driving, and it has the same kind of flavor of problems. It's hard to speculate on timelines, but where do you see the evolution of autonomous driving? Are we going to be riding in Ubers driven by computers in the next decade, or is our car going to be just a lot safer next year?
Yeah, difficult question. I do think our cars are getting safer, just to be clear, in the sense that the warning signals and so forth are getting a lot better, even when you're driving yourself, to pay attention to things. And that's definitely improving quickly. I'm personally not anytime soon giving full control to a computer to drive me. Not going to happen. I'm going to have to see that, a lot more evidence that this is actually working. And right now, I don't think it's working. It's a work in progress. Yeah. And I definitely don't want to be the first one to test it.
Yeah, I share your concern. It's certainly an area that we're actively studying, trying to make the cars safer. My hope is that when my kids drive, there won't be accidents. They'll probably be driving, which is scary on many fronts, but there will be less accidents. Hopefully cars will be more intelligent about detecting things.
Yeah, but to double click on part of it essentially is the story is indeed very similar, because if you want to build the best self-driving car, and let's say you first limit what you're going to be doing. That's the traditional approach to engineering. You say, let's make it more narrow, maybe we can handle it.
Right.
And it seems like the only way to handle it is to completely have a region that's fully in your control. Once you go beyond that, you say, let's just do highways. That should be easier than the rest. There's just still these special things that happen on highways periodically, maybe after an accident or something, animal runs on the highway, this or that. And you have the same pattern. Right. You're better off still collecting data in cities, everywhere else, because it actually covers special cases more quickly than if all you do is data collection on the highway.
Yeah, makes sense. All right, so one of our goals in this panel was to not just talk about AI, but entrepreneurship. You've been doing a lot of cool stuff, both launching companies and even getting involved in venture capital itself. Maybe you could talk about your journey to startups, to entrepreneurship, and how did it go?
Yeah, I didn't get involved as early as you did. You already got involved as a grad student, obviously, and very successfully so. But in my case, when I was a grad student, I was always thinking it'd be really great to not just work on research that will stay research and stay at the university, but somehow can transition in the future. But the topic I chose, artificial intelligence, back then in the early 2000s, wasn't really that ready for commercialization, so just kept plugging away at it, hoping that someday things would start working well enough that real products can be built. And that essentially started happening around 2012 with the big ImageNet breakthrough. And so a little after that, what happened is the first company I started was together with Arjun Singh, Berkeley undergrad and grad student, Sergey Karayev, Berkeley grad student, and Ibrahim Awal, Berkeley undergraduate, which is Gradescope, and essentially was born out of pain. and I think a lot of good companies are born out of pain that you don't want to tolerate anymore, namely the pain of grading students' homework, exams, projects. It's such repetitive work. Sure, I mean, to be fair, sometimes there's something creative in the mix, but most of the time, it's kind of, there's a correct answer and as many wrong answers, and all the variations of wrong answers, tease those apart and understand how much credit you should still give and so forth. Just a ton of work. And what we did was at first we just looked at the workflow, and we just were annoyed by the workflow that we had to pass these stacks of paper around. We all have to get together at the same time, pass these stacks of paper around and grade. What if we scan it all and put it online and all bring our laptops and grade it on our laptops, but still grade by hand? And we did that, and there was no AI. There was zero AI, but it was faster. It was a lot faster. And we actually convinced many of our friends, colleagues to do the same thing. try it out, and they're like, oh, it's faster for us too. First in computer science, then in chemistry was a very fast, quick adopter. Econ was a very fast adopter. Math, a lot of the big undergrad courses adapted it very fast. And at some point, we're like, okay, well, shouldn't we be able to now do it automatically? And that's where the AI fund came in. But interestingly, it didn't start as an AI thing, even though we knew that in the long run that might be part of it. It was just a pure interfacing thing. How to make people's workflow easier, and then the AI makes it like another 100 times easier now. But
yeah, I use Gradescope. I'm teaching a 2,000 student class this semester. I would quit if we didn't have Gradescope. It fundamentally changed the way we approach grading. It allows us to have more interesting questions on the exam. The AIs are now able to help us cluster responses and grade them much more efficiently. So it's pretty critical to education at Berkeley, and it's pretty cool. It came from Berkeley. That was your first company, and then you're also involved in Covariant. Maybe talk about that. It's more in the robotics space. And
yeah, so it's a slightly longer lead-up story here in the sense that Covariant is kind of the company I feel like I was meant to start all along, which is I've been doing AI and robotics research for so long, and as a grad student, as a professor, and then around 2017, it just seemed like the time was right. We had made so much progress on making robots learn, which opened up many new opportunities for robots in terms of helping out in less structured environments than you had in the previous generation of robotics, that I actually sent an email to all my students at the time. I said, hey, seems like maybe the time is right to start a company in the AI-powered robotics space. And I was kind of curious what they would respond, because I mean, the research in the lab was going great. Like we're writing many papers, many of the most highly cited papers. Their careers are like going so well. It would be like a real departure from what seemed like the hottest thing to be doing at the time, which was writing AI papers, to start a company. It wasn't as much of a thing yet back in 2017. Though certainly there were some AI companies. And sure enough, two of them replied, Rocky Dwan and Pieter Chen. They replied, they said, we've been talking to each other about the same thing. Let's exchange notes and see if we are thinking in the same direction. And sure enough, we were thinking in the same direction, and companies had started to reach out, seeing talks about our work that we gave, and being like, can't this help with our assembly line, supply chain? Can't this help with our warehouse pick and place? Can't this help with our, we had a hiring person, an HR person, recruiting person from hotel chain reach out. She was like, I've seen your Berkeley talk, your OpenAI talk, because I was also at OpenAI at the time. And it's like, can I hire some robots from you instead of people, because we can't find the people? And it felt like the writing was on the wall, that it wasn't just us thinking the technology might be ready, but that the people who would buy the technology were also looking to buy it. And so we decided to start Covariant in late 2017. Me, Rocky Dwan, Pieter Chen, and then Tianhao Zhang. They were all Berkeley undergrads, Berkeley PhD students. And kind of never looked back since. But I will say it was quite interesting, because we had no idea what we're going to do. I remember we went to talk with Kurt, because he had already experience in the entrepreneurship space. We went to talk with Scott Schenker quite a bit, who had sold his company to VMware a few years ahead of that, and of course one of the co-founders of Databricks. Yeah. And so we talked with a lot of the colleagues here at Berkeley who'd done companies before, often typically not in the AI space, but in systems. There had been many, of course, very successful startups already, and they made us feel like we should do this. We can probably do this too, which was really nice. And but it's funny, when we fundraised, we went to fundraise, and our story was we're leading the way in robot learning. There's going to be a lot of applications. That's the plan. And that was it. And 2 days later, we had enough offers to pick the one we liked best and start the company, which is pretty wild. It's a bit like the language model space now. It's like, we're going to build large language models. We're good at it. And it's like, okay, here's a term sheet. Here's a check. Yeah. It's kind of the same process.
So I'm curious. So if you were to do that again today, do you think in robotics that would work?
I think robotics is harder than people expected, and the reason is because the physical world is very unforgiving. When you make a mistake in the physical world, it's often hard to patch up those mistakes. When you make a mistake in the digital world, obviously there are certain mistakes in the digital world that can have big consequences, but a lot of digital world mistakes are easy to just make a quick edit to whatever the digital artifact is, and it's taken care of. Physical world, we actually thought about doing self-driving cars at the time. We figured that's completely out of the question because, that's just, the failure cases are just too costly. We said we're going to do robotic manipulation, so it's easier to fix up mistakes. We met with 200 companies and we concluded warehouse pick and place is exactly where the sweet spot is. There's a lot of demand, and you can have processes that fix things. So if your robot is 99% reliable, the 1%, or at this point we're at, I think, 0.1%, the 0.1% that it's not doing the right thing, it's easy to have mechanisms to reroute things to people who will take care of things and fix it up and won't cost them that much effort. But yeah, I think today robotics is not going to be the easiest space to fundraise in. I think digital is going to be easier, but I would say, hey, that often makes it the better thing to do. It's like the thing not everybody else is doing right now.
Makes sense, makes sense. We're almost out of time. I'll ask maybe two last questions. So we'll start with, often when you launch a company, you make mistakes. And sometimes those mistakes, you don't like to talk about them, but they teach us lessons. Can you recall any major kind of things, maybe not mistakes, but like early lessons you learned in this process?
Yeah, I think there's a lot of lessons learned. I think successful entrepreneurship is not knowing everything ahead of time. It's just iterating and learning lessons quickly as you go along, because you're always doing something new that hasn't been done pretty much. But there are some reusable lessons. I think one is, this is a lesson we learned in a good way, in a positive way. Connections really help. If you have the right connections, it opens doors very, very quickly. You get the right conversations. So in the early days, us talking with Kurt Koitzer here, with Scott Schenker, who had been there before, opens up doors to talk with the right people, and everything moves a lot faster. And you only need, in some sense, one starting point of a connection. Once you have one connection, they know other people, and so as long as you make a good impression in each of these meetings that you have, they'll often propose to introduce you to more people. And so having one starting point can go a very long way. We had more than one, which is, of course, even better. But I think that's really good to know. And I know it's, of course, usually the talk is the opposite way. Things should be more fair, and everybody should be in an equal playing field. But the truth is that connections really help. And if you have any, it'd be stupid not to try to leverage them. I think another thing that we learned is recognizability really matters. So I think when we look back at how we ran Gradescope versus how we ran or are still running Covariant, with Gradescope, we did kind of the academic thing, put the students front and center. The students are doing the hardest work at the company now. They should be the face of the company. They should be, but it turns out then you don't get the same level of visibility, the same level of leverage, whether it's with customers or whether it's with press and so forth. Whereas with Covariant, we knew the 3 students are going to put in more cycles than I'm going to put in because I'm also still at Berkeley. But nevertheless, I'm going to be the main face of the company, at least for the first who knows how many years. And it's just very different when you do that. And it was a very explicit discussion. And now, maybe if the students were very fame-driven and, I need my face in the press-driven, that's not the right decision. But if all they want is build the largest, most successful possible company, that was clearly the right decision. And then I think maybe a third lesson that's very Covariant specific is you want to be as close as possible to your customers. And everybody will tell you that. In fact, if you take Kurt's entrepreneurship class, he will tell you, talk to customer, talk to customer, talk to customer. Sure. But at Covariant, in the early days, we were hoping that maybe you can just build the AI, ship off the AI, others will use your AI and build the application with that AI, to deploy the robots. And we have actually many successful deployments of robots that are installed by others using our AI. So that path works, but the pace of progress is slower. When we started in parallel, actually doing it ourselves, you go so much faster. Because once you do it yourself, even though it costs you more effort, you need to raise more funding because you need a bigger team to also install the robots. You meet the customers, you meet their pain points, and you can zone in so much faster on meeting all the requirements than if you have this middle company that is effectively the distributor and the installer of your system. And so I think, even if in the long run, maybe who knows what it'll be, I think early on, you want to be like in the room with the customer, delivering your product, getting that feedback. That's something we did really well at Gradescope. We would be like at the grading sessions with the TAs of other classes and helping the TAs, making sure we understand why they're stuck on something. And I think at Covariant in the early days, I guess we're a little too optimistic to just build AI and ship off the AI. You need to do the whole thing to the customer.
Yeah, it makes sense. At Aqueduct, my current company, we definitely had a similar lesson. Really chasing the problem, understanding the customer in the AI space is critical and often overlooked because we have very smart grad students who are like, we'll solve hard problems, but ultimately we need to solve their problem, which is the customer. Right. So getting that right was definitely a lesson we learned too. All right, so we're basically out of time. Are there any last thoughts you'd want to share? So get suggestions, guidance.
I'd love to swap roles with you next year.
Okay. Yes. Okay. I think, so we're out of time. I appreciate having you here. Thank Pieter.
Thanks, everyone.